Hello, my name is Harish. So here is the final task that I have completed, and the result I will show you, like how it takes an video as an input and converts the any given language to the particular Hindi language. In our given video it was Kannada language. Now I have converted that to Hindi language with lip sync moments.
अब हम स्वच्छता के विषय में चर्चा कर सकते हैं। स्वच्छता क्या है? स्वच्छता का तात्पर्य स्वच्छता से है। हमें स्वच्छता क्यों बनाए रखनी चाहिए? चूंकि इस नौकरी में आप हमेशा बच्चों के साथ रहते हैं, इसलिए यह बहुत जरूरी है कि आप स्वच्छ रहें।
As you have seen the demo video, so now let me just go through the pipeline of this complete project. So this pipeline describes the process of automatically generating a Hindi dubbed version of a video using AI. The system first takes the input video and then extracts the audio track from it using video processing tools such as FFmpeg. Since long audio files can reduce transcription accuracy and increase computation time, the pipeline performs silence detection to segment the audio into smaller speech, and then each segment is then processed independently. As you can see, there are three segments. Each segment is processed independently. For every segment, the system first performs speech to text transcriptions. The system first performs speech to text transcription to convert the spoken Kannada audio to given text. Transcribed text is then passed to a translation module which converts the Kannada text into Hindi while preserving the meaning and context of the original speech. After translation, a text-to-speech model generates Hindi audio for each segment. Once all segments have been processed, the generated Hindi audio segments are merged together to create a complete Hindi audio track. This final Hindi audio is then passed to a SAT talker. Before that, let me just tell you that for voice generation, here we have used TTS. For TTS, the voice generated is not accurate, so we brought the Sarvam AI API key to generate voice. So when we use Sarvam API models, you can get any translated language generated voice in an accurate, where we can add it, merge it to the video, and we can send it to the SAT talker. So where the final Hindi audio is then passed to a SAT talker, a lip synchronization model that animates the speaker's face and aligns the lip movements with the generated Hindi speech. The output of this step is the final Hindi dubbed video, where the speaker speaks and appears to naturally speak Hindi while maintaining realistic facial movements and timings. Now let's move to the resourceful architecture. How did we get high quality without spending any money? So this architecture demonstrates how the system achieves high quality AI video dubbing while keeping the cost close to zero. It's actually completely zero. We have not used any single money on. The pipeline begins with the input video, which is processed using FFmpeg, an open source multimedia tool. FFmpeg is used to clip the required segment of the video and extract the audio track efficiently without requiring any paid software. The extracted audio is then sent to Sarvam AI's model, which are used for three tasks: automatic speech recognitions to convert the spoken language into text, then for translation, then finally the translated text has to be generate voice. So for text to speech, to generate Hindi audio, we have used Sarvam AI models to get accurate generated voice. Using Sarvam's free tier allows the pipeline to perform these AI tasks without expensive API cost. Once the Hindi audio is generated, it is then passed to SAT Talker. Uh, an open source SAT Talker is an open source lip synchronization model that animates the speaker's face and aligns the lip movement with the new Hindi generated voice. Finally, the processed video is produced as the final dubbed video, where the speaker appears to naturally speak Hindi by combining open source tools like FFmpeg and SAT Talker with free AI services from Sarvam. The system achieves a resource efficient architecture that delivers high quality result without requiring any paid infrastructure or large computational resources. Now there was a question, what if, explain how would you modify the script to process 500 hours of video overnight if we gave you a budget. So to answer this, to scale these systems to process 500 hours of video overnight, I would convert the current sequential pipeline into a distributed batch processing architecture. Instead of processing an entire video at once, the first step would be to split the video into smaller segments, such as 15 to 30 seconds clip, and each segment can be processed independently throughout the pipeline. Then these segments would then be placed into a task queue managed by a system such as Redis or RabbitMQ. multiple worker machines equipped with GPUs who pull tasks from the queue and run the pipeline stages, speech recognitions, and then it will move to the translation, and then next it will move to the text to speech generation, and finally lip synchronization on different segments simultaneously. So this allows hundreds of segments to be processed in parallel rather than sequential. So for large scale execution, the workers could be deployed using containerized services with Docker and orchestrated with Kubernetes, allowing the system to automatically scale depending on workload. For storage, for intermediate files such as audio, segments, and generated videos would be handled through by storing it on cloud storage like AWS S3. Once all segments are processed, the final step would be to merge the processed segment back into the complete dub video, again using FFmpeg. So by parallelizing this pipeline across multiple GPUs and distributing the workload across several machines. Now let me go through our project folder. As I have created the main project folder with name, and then under that we have created three subfolders. One is input and one is modules and other is outputs. This SAT talker you are seeing is just I have downloaded the models, and now I'm going to explain about these modules that we have created. The for each video, first we are going to clip that video. If for our project the video length is of 5 minutes, as you can see the given source video is of 5 minutes, we have just extracted the clip of 15 seconds. We have given the input video, then we have used this ffmpeg for extracting the clip. As you can see, we have defined the function. In that function we are going to pass two arguments, one is input video and one is output video. The output video which has come from this extracted is going to store it in the outputs. You can see here the extracted clip mp4 video that has come from this function, from this Python file. Now there is an extract audio Python file also where we are going to get the audio for that video. So we have extracted the small seconds just to show the how our project works for that 15 seconds of video and audio file, as we are running it onto the CPU. So we have extracted this small 15 seconds video. Now there is an different modules. One is a transcribe. If the audio file, what if the video is too big? Now for that we have created audio segments where for each big video file we will get the big audio file. For that big audio file to translate to transcribe, we are going to divide it into the different segments based on the video size. So we are going to work parallelly with those segments. If there are multiple GPUs on our system, we are going to provide each GPU to work simultaneously and parallelly. Now the work can be so fast, work can be done so fast. And now we are going to the pipeline for the each segments. If the audio is short, in our case it's just 15 seconds, we don't need to segment anything. No, we just move it to the pipeline. So the first is that we are going to transcribe. We are going to provide the audio file to these functions where it is going to transcribe those audio file voice to the text, and that text we are going to provide it to the translate functions, where the translate functions uses servum API key, and we have used here is Mahura V1 model just to get accurate translations. For transcription also we have used servum models to get accurate transcribe text. Now we are going to generate voice. For that translated text, whatever we get from this file, we are going to pass that to this generate voice. The translated text and the output audio and the reference audio, the three we are going to send it to these functions. Now we'll get the generated voice in the output. The generated voice can be Hindi audio wave, which will can be 17 seconds for the 15 seconds video also. Now let me go through this dub video Python file where we have given, where we will go through the pipeline. So first we have imported every modules that we have created here. So the first module that comes is extract clip based on the input video, and we are going to extract and we are going to get the clip video as an output. The clip video is then sent it to the extract audio functions. We'll send it to this module, extract audio module, where it just gives the audio file. The audio which are extracted from this clip video, we'll get it as an audio file. Now that audio file we are going to store it as a segments. If the audio file is too big, we are just going to split it that audio file and we are going to store it in each segments. So now we are going to loop through the each segments, and for each segments there will be a pipeline of transcript and translate and generate Hindi voice. As you can see, for each segment, whatever we get the audio file, now here we have stored that audio file. Now that audio file is splitted into segments that we are going to store it in a segments. And now here we have just defined an Hindi audio segments. Now we are going to loop it through the each segments. For each segments, we are just pass it through this transcribe model where it generates and text, and that text can be of anything. If the audio file is of Kannada language, the text is going to be Kannada text, and then we are going to use translate module to translate that Kannada text to an Hindi. Here we get the Hindi translated language. Now we are going to print that Hindi language, whatever we translated. Now we need to make that text to an audio file, so we are going to replace that segment to the audio file, and we'll get the segment Hindi audio. For each segment we are going to get the Hindi audio file. Now here we have used this generate voice. This generates Hindi speech audio from the translated text, and this adds the generated Hindi audio file to the list of audio segments. At starting, we have defined a variable, a list, which is Hindi audio segments. So the every translated text and generated Hindi audio file, we are going to store it, append it to the Hindi audio segments list. Now we are going to merge Hindi audio segments. This creates an empty audio object where all Hindi segments will be merged. Now let's loop through all generated Hindi audio segments, and this loads each segment and appends it to the combined audio file. Now we are going to export the merged audio as put Hindi audio.wave. Now we'll just print the statement to confirm the merged Hindi audio has been created. Now we are going to merge audio with video. If we want to just merge Hindi audio with the video, we can use this function, and this merges the Hindi audio track with the video to produce the final dubbed video. This just prints the final success message, and that's it. This is a final pipeline flow that we have used in this project.